Let me tell you about a problem that I saw on a third grade Kansas assessment, okay? It was something, I'm pretty sure it was like this. There were 9 buses parked end to end. Each bus was 15 meters long. What was the total length from the beginning of the first bus to the end of the last bus?
It would be 15 times 9.
It would be 15 times 9, okay? Now, our problem today is a 5th grade problem, so it's a little different. Don't attempt to solve it yet, okay? It says the length of a school bus is 12.6 meters. So instead of 15, like on the 3rd grade problem, they're 12.6, okay? If 9 school buses park end to end with 2 meters between each one, what's the total length from the front of the first bus to the end of the last bus? Now we know there's a decimal, that's a difference. But what's the main difference between this and the 3rd grade problem? Rustin?
There's 2 meters in between.
There's 2 meters in between each bus. Now we still have 9 buses, don't we? Okay? So what I want you to do is I want you to figure out what you would draw to show this. And then we're going to talk about it, and I might pick a couple of you to come up here and draw what you did, okay? I'll push pause for a minute. Okay, so we have 2 ways to draw this. Cooper just pretty much separated it into the gaps plus the buses. This way shows 9 buses with 2 meters in between each, okay? Either way, you've got 2 parts, right? You've got to do your gaps and you've got to do your buses. Now, what if I added 1 more bus to make 10 buses and then crossed it off?
Never mind. You could do that.
I could do that, couldn't I? And these are numerical expressions, which we probably need to practice anyway. So let's get busy practicing it.
I did that.
Okay? So go ahead to one of your drawings, add a bus, and then subtract it. Now we don't need to add a gap because all we're doing is changing the 9 to a 10 so we can do it in our head. Now if I were going to do this in my head, oh, by the way, if I do 12.6 times 10, what do I get?
1,000. 100.
No, I don't. I move the decimal.
120.
I hop the decimal and I get 126, okay? So there's half my problem. Now I'm going to subtract 1 bus. So I'm going to subtract what? 1 times 12.6. So what will I subtract? 12.6. Now this is where it gets a little tricky. So I'm going to use standard algorithm on this. I've got 126 meters minus 12.6
You have to
meters.
drop one, like borrowing. So
I do. So pretty much I've got to line up my decimals there if I'm going to do it this way. The other way is the way you recommended, take the decimal out, then put it back in. But I want to do this, I want to practice this because we haven't done it for a while. So this would become a 10, right? And this would become a
5,
okay, 10 minus 6.
4,
Bring down your decimal. 5 minus 2.
1, 1.
So 113.4 meters is how long the buses are.
Then you have to subtract 60.
You're close.
Add 60.
Would I subtract those gaps or add them?
Add them.
Add them. So now I'm going to add 16 meters for my gaps. So there's a little bit of decimal practice for us, boys and girls. It's been a while, hasn't it? But the total distance from the front of the first bus to the end of the last bus is what? 129.4 meters. All right, let's go to the lesson. So instead of multiplying with the standard algorithm, we subtracted and added. Okay, this lesson is different for a few reasons. Okay, first of all, we have to take the turtle and go put it in a courtyard somewhere or something. Take it home, let it go in the country, but the turtle is no more. The turtle is being replaced. We now have a turkey.
Oh.
Okay, and you'll find out why in a minute. But go ahead and draw your turkey. I need everybody to do it for me on this first problem, and then you can make up your own mind. I need everyone to do it for me on this first problem, and then you can make up your own mind. Okay, now this could have been another type of animal, but I picked turkey because we are in November. And so we might as well be festive. Okay, how does my area model look a little different?
3 boxes.
Going down, right? Okay, so I know 524 is on top of my area model. So tell me what to write.
524.
Good. And then going down, how would I take 136 and put it on there?
You put 60, 30, 100.
So you're saying put the largest number at the bottom still.
Yeah.
That's correct. Now, when we were working on whiteboards the other day, we actually had to highlight without a highlighter. And so we did a little bit of this. That's an option for you, or you can use your highlighter. But I want you to make those numbers pop out at you or stand out a little bit, okay? Okay, so I want you to, with your best calculating ability, figure out what goes in each box and add them across. Now, who stayed with me after school last week and we used a little bit different strategy? When you get to, can I have your attention for a minute? When you get to adding across and you get confused like we're going to get on the next problem because it goes up to the millions place.
Oh, yeah.
I would suggest just write your 3 numbers down, add them up. Somewhere else on a scrap paper or on the edge of your paper or something so that your adding across doesn't mess you up. Because I think that's what was happening, okay? So you don't have to add across if you're confused, write them down. All right, here we go. You go ahead and do it, and I'll do it, and we'll see what we get. Don't start the standard algorithm yet, please. I have a reason. Oh, by the way, boys and girls, please don't write commas in the numbers until the final product. And I'll explain why here in a little bit, okay?
Man, that's an open side.
Once you have all those added up, and it's okay if you don't want to add across like I did. Can you tell that I added these 2 small boxes and wrote it over here? Okay. So that's my strategy on this one. It's not going to be my strategy on the next one. Now I'm going to put my comma in, but not before. Okay? Now that's a review of the area model. And we need to, the main reason we need to make sure we add these correctly is because this is how we're going to check our standard algorithm. The standard algorithm is difficult. And if I'm going to check it, then I need to have the correct answers over here, okay? So let's take a look at the standard algorithm. This is where I need you to kind of help me say the answers, and we're going to talk through where to write everything, okay? On this first one for sure. So 6 times 4,
24.
okay? Regroup the 2, write the 4, and you can do this right along with me, okay? 6 times 2
12.
plus 2.
1.
14, regroup the 1, write the 4, cross off the 2. Good.
And then 30.
5 times 6 is 30, plus 1,
33.
so cross off the 1. Now, do we have a match?
Yes.
Yes. Okay. So the second row of multiplication, anything times a multiple of 10, add a 0 to the end. Very good. Okay, this is where I'm going to draw that thing that hangs down on the turkey. What's that thing called? Waddle. Waddle. I don't know why they didn't call it a gobble. That would make more sense, wouldn't it?
I already wrote it.
Okay, so some birds have a collar. So if you still want to be in the habit of crossing off that first number that you multiplied, go ahead. I think birds will be fine with a collar, don't you? I know ducks have them. Okay, so now I'm working with this number, and gosh, if I had a red colored pencil, I might even color that red so that I don't mess up what number I'm multiplying now, okay? So I've got 3 times 4, okay?
Well, you can just change it.
And then 3 times 2 is 6 plus 1,
7.
cross off the 1, and 3 times 5,
15.
okay, do I have a match on my partial product? Yes. Okay, I'm not going to cross off that 3. I'm just going to know that the last digit is the one I'm ready for.
I'm going to color it in.
Oh, by the way, anything times a multiple of 10 really won't work on this row.
Any multiple times 100.
It's going to be 100. Now, or it's going to be a multiple of 100. Now, here's what I want to clarify. 100 is a multiple of 10.
Right, yes.
But how many zeros does it have?
2.
So that's the most important part
Now, that's 2 is messing up on
on IXL. Okay. So now that we have that established, it's a multiple of 100. I haven't come up with a rhyme for it, but maybe we can work on that later. And then I'm going to multiply 1 times 4, 1 times 2, 1 times 5.
5, 2, 4, 2.
Now, do I have a match on this partial product?
Yes.
Okay, go ahead and add them up. Now, here's why I don't want you to put your commas in yet. What if I went through and I had my commas? What could that comma be mistaken for?
Decimal.
A 1. Couldn't it? If I made it too big, then I might think I need to add a 1 in there. So I want you to keep those commas out of this problem. How long is it going to take me to get them out of there? Until we're finished, okay? So now add it up. This is going to look familiar to us, isn't it?
12.
Now I'll put my comma in. And I sure want to make sure that it doesn't look like a decimal. Okay, so those are some differences. Now we're going to move on. Here's the good news, boys and girls. No one else got past the next problem, and I think we might. So thank you for being so ready to do your work today. How's this one different?
Has 4 digits by times 3.
Okay, so how is this problem different?
It has 4 digits times 3.
4 digits times 3, which doesn't change the turkey. And it doesn't change the multiple of 10 and multiple of 100. So let's talk about where to write this. 4,519. What do I write?
4,000
Plus.
500 10 9
Good. And
300 and 6 20.
okay. Now here's what I'm going to tell you right now. I want everyone to stop and listen to me. Are you ready?
Yes. No, not yet.
The first two rows go pretty easily. The last row bumps up from the 10,000ths place to the millions.
Oh my gosh.
So when you're adding, I would highly recommend that you double check. If you choose to add across, double check it off to the side using the standard algorithm. Okay?
Okay.
All right. Give this a try. Don't forget to highlight. And we'll try hard not to throw any highlighters across the room. Okay.
Lupita threw a marker. She's like apple. Hey, bro. Stop it, Jose. Who was that? That was
Okay, let's just work. Take a look at the box I just did. 2 times 5 is 10, and you still have to have 3 more zeros. So that one might confuse you. Okay, I would also recommend putting your commas in on this last row so that adding could be somewhat simpler. Okay, now I'm choosing to take these 4 numbers and add them up in a different place because I want to make sure I get it right. Okay? Now this is just going to give me my third partial product.
Wait, how did you get 2 zeros? Oh yeah. You're right.
So as we complete the standard algorithm, good luck drawing a turkey with that long of a head.
Oh.
Okay, 6 times 9.
Big head.
Help me.
9 is 54.
54. 6 times 1 plus 5.
11.
11. Cross off your 5. Even if you're still working on the area model, move away from it and go to the standard algorithm. 6 times 5 is 30 plus 1, 31. Regroup your 3, cross off your 1. 6 times 4,
27.
24 plus 3.
27.
Do I have a match?
Yes, ma'am.
Thank goodness. Anything times a multiple of 10?
Add a 0 to the end.
Thank you. Waddle.
Wow, wow, wow.
I want a red one, don't you? Okay. Oh, and if you want to put a collar on your bird, do it.
It's choking though.
2 times 9.
18.
Regroup the 1. Why are you talking? 2 times 1 plus 1.
11.
3.
3.
5 times 2.
0.
10. Regroup the 1.
Yeah.
I knew what you meant. And 4 times 2, 8. Add 1 more.
9.
Do we have a match?
Yes.
Okay. Now for the final. Anything times a multiple of 100,
Add 2 zeros to the end.
we got to figure out that rhyme.
Anything.
3 times 9,
7.
27. Regroup the 2. 3 times 1 plus 2.
5.
Cross off the 2. So far, so good?
Yes.
All right. 3 times 5,
15.
regroup the 1. And the 1's just out there. 3 times 4 is 12.
13.
Add 1 more. Do we have a match?
Yes.
Oh, goodness. Add it up. Let's see what we get.
I got the same answer.
So how do you say that number?
1,473,194.
That's excellent.